Our team is creating this presentation for IE441, Senior Design in the spring of 2021 at Iowa State University. My name is Lejuani, and my teammates are Mohammed, Ahmed, and Owen. We had the pleasure of working with the John Deere seeding unit to analyze alternative conveyance methods for planters that they manufacture. Some specific details will be left out of this presentation for the sake of confidentiality. Planters are towed behind a tractor and are used to sow seeds at a determined width into soil. The ones we're dealing with can be as wide as 50 feet and as heavy as 30 tons. In the current system, planters travel through a 14-station line where they are assembled. Each planter is attached in pair with an MGV tugger to travel between each of the 14 stations. And at the end, an MGV tugger travels back to Station 1 after the planter is completely assembled at Station 14. The current MGV tugger conveyance system is approaching the end of its life cycle and impending failure. The fleet is 20+ years old and increasingly costly to maintain, with 7 tuggers already having been decommissioned. So we were tasked with finding an alternative conveyance system that 1. Reduced the number of reported safety issues by 20%. 2. Had the capacity to move planters that are 10% heavier, that is, 50.5 thousand pounds. And 3. Reduced the operational costs of conveyance by 20%.
Convoy's operational costs collected and calculated during our current state analysis create a baseline to compare alternative convoy's methods. Our current state analysis confirms the increasing tugger fleet maintenance costs. Analyzing conveys as safety reports allowed us to categorize 30% of near misses due to low operator visibility and 60% of near misses due to improper tugger planter attachment. We will address these safety concerns in the following slides. Low visibility accounting for 30% of near misses and can be addressed by tugger mounted cameras. We suggest installing cameras on telescoping arms mounted on top of the tugger that are connected to a monitor inside of the tugger. These cameras can be adjusted to give an operator a full range of visibility between tugger and the planter. These cameras act like reverse cameras in modern cars, so we just suggest implementing the pictured model for industrial truck cameras and 1 monitor for each tugger in the fleet. Improper tugger planter attachment accounting for 60% of the near misses can be addressed by proximity sensors. The attachment mechanism utilizes a swivel bracket and 2 pins. Proximity sensor can detect when pin is not properly connected and raise alarm or prevent tugger motion. We suggest implementing 2 proximity sensors per tugger, 1 sensor for each pin. Additional safety features such as mirrors and swivel seats are an affordable way to improve safety and by increasing visibility, and these are 2 additional options outlined in our work.
We considered MGV, AGV, rail, crane, and chain combined system in our alternative analysis. We compared the customer requirement and functional requirement using quality function deployment and determined that MGV and AGV fleets are the best alternatives.
We gathered quotes for leasing and purchasing an MGV fleet capable of tugging 50,000 plus pounds. The operational costs, cameras, and proximity sensors are all included as costs in each option. Leasing an MGV fleet has a lower initial investment cost than purchasing a fleet, but it quickly becomes more expensive than buying the fleet outright. We suggest purchasing a fleet if an MGV conveyance alternative is selected. We gathered quotes from Transbotics to purchase an AGV fleet that fulfilled the capacity requirements previously mentioned. The cost of proximity sensors is included, but travel, changeover, and camera costs are eliminated with this method. An AGV fleet has the highest initial investment cost, but has the lowest variable cost. It automates safety and therefore fulfills our number 1 objective. If this AGV fleet is within budget, then we suggest this conveyance alternative. Otherwise, we suggest purchasing an MGV fleet.
We addressed Objective 1 by suggesting implementing proximity sensor and cameras or automation to reduce 60 and 30% of the recorded safety near misses respectively. We address Objective 2 by sourcing conveyance alternative capable of moving 50.5 thousand pounds, allowing for growth and flexibility in the future. We address Objective 3 by including an AGV conveyance alternative that is estimated to reduce operational costs by 85% compared to the current conveyance method.